You can find the answers to the math pretest online. I will post the answers, but here I'm trying to go through what is some of the thinking that should have gone through as you were working these problems. Now the first little thing on here, it says show your work. Okay, there were people who had totally ignored that and only had answers. If all you have is an answer to a problem, when the AP readers read that, they think you must have copied this from your neighbor, otherwise you'd have some work, and you get no credit. So no work, you get no credit. Be careful. So what are we doing here? We're saying we have 0.525 grams for a paper clip, and we want that in kilograms. So you're supposed to know that there are 1,000 grams in 1 kilogram, and what we're going to do is use this as a conversion factor. Now notice also it's asking for your answer in scientific notation. So we start out with our given number, and then we're going to use a conversion factor and say that there are 1,000 grams in every kilogram. So when we multiply, we see we're going to get 0.000525 kilograms. Now, you want to put that in scientific notation, so we're going to move our decimal place 4 times. So we're going to say this is 5.25 times 10 to the negative 4th kilograms, and that's our answer. For number 2, here we have some density of 1.48 grams per cubic centimeter. What's the volume if the mass is 5 grams? Now the way I would do this is use the density as a conversion factor. Whenever I see something per something, I can use it as a conversion factor. So the way I would write this is starting with 5 grams, then we use our density, 1.48 grams per cubic centimeter. So grams drop out, and so I say 5 divided by 1.48, and I get 3.38 cubic centimeters as my answer. Now, reading through papers, I can see a lot of people, what they did is say, okay, density, I know density is equal to mass over volume, and they know that the density is 1.48 grams per cubic centimeter. Okay, I know the mass is 5 grams, and I'm looking for the volume. Now this will work perfectly if you do it correctly. Now I saw some people make mistakes, and what they did is they said volume equals 1.48 times 5, and they're just making an algebra mistake. They're really solving for 1 over volume. But we were really doing saying volume is 5.00 divided by 1.48. This is grams, and this is grams per cubic centimeter. So we get 3.38 cubic centimeters. Now, if you look at this, you can see we're doing exactly the same thing in both cases. We're taking 5 divided by 1.48. We're taking 5 divided by 1.48. But we can do it 2 different ways. Now, the idea here is if you're going to use a formula, then it's a very, very good idea to write the formula first, then substitute your numbers into the formula, and then you can get your answer. That way the readers for the AP test will know exactly what you're doing. If you do those 3 steps, formula, substitution, and then answer, you're home free. The density of aluminum is 2.70 grams per cubic centimeter. If a cube weighs 13.5 grams, what's the length of the edge of the cube? Okay, well that's a little weird. So say if we had a cube, then we want to know is what's the length of one of those edges. So if we knew the volume, okay, the volume is the length times the width times the height, which is length times length times length. So it's the length cubed. So if we knew what the volume was, all we have to do is take the cube root, and that would give us the length. So what I would do is use my 2.70 as a conversion factor, and I'd say 13.5 grams. Then I would say there's 2.70 grams in 1 cubic centimeter. And when I divide those two, I will get 5 cubic centimeters. So that's my volume. Then I would take the cube root of that, so my length is equal to the cube root of 5.00, and that turns out to be 1.71 cubic centimeters. No, 1.71 centimeters. The 5 was cubic centimeters. When I took the cube root, I got centimeters, and that's my answer. I saw quite a few people who got to this part, and then it magically turns into this. You need to show, what you're doing. If you just somehow just showed that it was a cube root, even wrote cube root, but it shouldn't magically turn from one number into the other. It should have some reason why you're doing this. Convert 15 years to seconds. Okay, people did this very, very well, as far as got the right answer. The work wasn't very clear, but he had 15 years. And again, I would do this with conversion factors. And I would say that I know that 1 year is 365.25 days. And I know that 1 day is 24 hours. And I know that 1 hour is 60 minutes. And I know that 1 minute is 60 seconds. So when we get all done with this, then we're going to get a big number. So 473364060 seconds. Now this is the perfect time to use scientific notation because that number is just huge. And we only have 2 digits here, 15, 24, 60. So we make this 4.7 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 10 to the 8th seconds. That'd be a much more manageable sort of number. This one here, almost everybody got this. 350,000. Okay, write that in scientific notation. So the decimal point, we're going to be moving that 5 times. So the answer would be 3.5 times 10 to the 5th power. Now there's no units on this. It's not actually mean anything. It's just a number. Now I did see some people write 335 times 10 to the 4th. And that is, I would call that exponential notation, but that's not scientific notation. Scientific notation uses the number between 1 and 10, and it goes back to the old ideas of the slide rule, which we won't go to now. How many centimeters are in an area of 4.21 square inches? How many square centimeters in square inches? Now that's a little odd. Now we do know that there are 2.54 centimeters in 1 inch. And maybe we know that, maybe we don't know that, but that would be given. We're knowing this, what we do is go back and say, we want to convert, so I can say 4.21 square inches, and we want to change inches into centimeters. But what we're going to do in this case here is we're going to square the top and the bottom. So that way we have square inches, and we're going to end up with square centimeters. So when we get all done, it's 4.21 times 2.54 times 2.54, and we get an answer of 27.4 square centimeters. So that's a little odd, but that works. The last one here is a simple percent error kind of a problem, and you definitely ought to know this. And what you're going to do is find out, well, how far are you off? So the percent error would be 2.7 grams per cubic centimeter minus 2.6 grams per cubic centimeter. And I just subtract my larger minus my smaller. And then divide by what it's supposed to be. So the accepted value is 2.70 times 100. And when I work this problem out, I get something like 3.70%. That's my percent error. Now, I saw a lot of people, all they wrote was 3.7%. But if this has three digits and this has 3 digits, then my answer really ought to have 3 digits. So we should make it 3.70. We'll go into that more. Now, one thing I did see a lot of people do, and I'm going to get a different color here, and that is all they did was take 2.60 divided by 2.70 times 100. And that gave them 96%. They're calling that 96%. And so they subtracted that from 100, and they got 4% as their answer. Now that is sort of correct, okay, but where it's wrong is here we're talking about, in our original, we're saying how much are you off? What's your error divided by what it's supposed to be? This one here is talking about not your error, but how much of it is correct. So this is like your percent correctness, and then you subtract from 100%. And this would actually work if you were to use more significant figures. So I saw a lot of people round that off to 96. What it really should have been would be 96 point, I think it was 30. And if you had subtracted from 100, you would have gotten the 3.70. So this is a little odd. I don't think I would do that on the AP test because it took me a while to figure out what was going on. The real formula would be this one up here. That's what I would give for my answer.